Welcome to another video on my home automation channel, and today I'm going to review this NetIO PowerBox 3PF. And this is the second product that I've received from NetIO. If you remember, the previous one was more like a switch, an inline switch, which had a power meter, and this time this is like an extension lead with 3 outputs here, and on the other end it is just a mains receptacle, and on the side we also find a network jack, so an RJ45, just a standard network plug. And from that you can probably tell that, well, this is a smart socket with 3 outputs, and because it has a network connection, this means that this particular model is designed to be controlled from a wire internet, so it doesn't have Wi-Fi, it only has the LAN connection. And if I want to compare it to the previous NetIO product that had, well, obviously it was a single channel, more like an inline switch, which had a power metering. This doesn't have power metering. This has 3 outputs that I can switch separately. In the beginning of the video I said home automation, but this is not really geared to home use. These NetIO products are not very cheap, and they are designed to be used in, let's say, in industrial settings, or probably in labs where high reliability and a more robust design is required. So the whole case is made from aluminium, and it has this special extrusion which has like a rail in the bottom. And you probably have seen these kind of installations in schools or in labs or in special offices where you would have a conduit on the wall or on the desks where mains receptacles and switches are mounted on a vertical surface, and this is exactly where it's supposed to go. So this channel here is the rail that this PowerBox can be mounted to. The other special feature of this product that it supports many different communication standards, how you can control this device from externally. So probably what we use most in this channel and what I tend to use in automation is MQTT. So this of course supports MQTT, but it also supports various HTTP based protocols. So there is an HTTP REST API, there is a HTTP JSON or XML communication. So again, depending on your system, you can easily control it with the sort of the language or the protocol which is most appropriate for your control application. And on top of that, to also satisfy the industrial users, it also supports Modbus over TCP. The only thing is that the unit doesn't support these protocols all at the same time. You have to specify in the configuration that now it's going to be MQTT or it's going to be Modbus or one of the HTTP protocols. In order to keep this video within a reasonable length, I think I'm going to just talk about 2 protocols out of this huge list. One is going to be the MQTT and the other one is going to be Modbus TCP. And just like with any other products with NetIO, there are a lot of application notes online. So you will see examples how you would do it with some of the HTTP JSON or REST APIs. And they also give you a couple of examples how some of these protocols are used with different products. Before I start testing, I just quickly want to go through the website. So this is the PowerBox 3PX, and the X because it is available in 3 different versions, as you can see here. The 3 different plug types, the standard, like the German European, the French, Italian, earth pin, and the UK plug. Of course, it would be 3 of any of those. Not in a mix and match like this one. If you scroll through the pictures, you can see also the slightly physical design for the English, obviously because it's a slightly bigger plug, and there is one on the mounting. If I can scroll to that one, you see the pictures for different. Yeah, so either it is like can be slid onto a DIN rail, or there are these mounting brackets. Can be used as well. I mean, these are not included in the package. These are standard stuff that are used in, electrical cabinets. So it should be easy to source them. And if we scroll down, we can see that just like with any other NetIO products, the device itself creates an own web service. So this is where most of the settings can be done. I'm going to go through that, and the various API protocols. So the JSON, the Modbus TCP, MQTT, Telnet, SNMP, so even some things that I haven't mentioned in the beginning of the video. And as you can see, for each of the protocols, you have different application notes that you can go through where they extensively talk about the various settings and how to use them. And out of the various HTTP protocols, so you can control this device using simple URLs or passing either JSON or XML commands in URLs. So again, depending on your application, how you want to use it. And I said labs and industrial. In the application, they also mention like AV equipment and lightnings in the conference room and switching the various AV devices. The product follows an industrial design, so the external case is an aluminum case, and as I mentioned in the beginning, it does have 0 voltage switching. So it's not a single solid state relay, it's a physical relay, but the relay switches when the AC goes through the 0 voltage curve, so it protects the relay and ensures the longevity of the device. Just like with the other NetIO device, you can specify the power on state of each of the individual output, and there is also an Android mobile app available where you can control the device locally over the same Wi-Fi or LAN network that the device is on. I have the NetIO PowerBox hooked up. As you can see here, you can see the network lead coming in from the left, and I couldn't find anything which would fit into the outputs. So I have borrowed the night lights from the kids. So there is one in socket 1, there is another one, the blue one in socket 2, and well, that's just too big for anything to fit in socket 3, so I'm not going to plug anything there. As you can see, the outputs are on at the moment. So at the moment, this device is 192.168.1.181, and if you just type it in any of your browser, then you will be presented with this website. And by the way, the default login is admin, so admin user and admin password. And now I'm already in. I can see that, well, obviously it's a PowerBox and it's called PowerBox-91. That's going to be important a little bit later. And you can see the 3 outputs, and I can control the outputs from here. And I can turn them on and I can turn them off as well. And then when you click on the icon, then it gets you to the settings, so you can rename it if you want a more descriptive name, or actually the name to reflect whatever is plugged into. There is an option to turn the outputs on for a short period of time, and you can specify the delay here, so that's 20 milliseconds. That's the default, and we are going to see some functions later on where this actually makes sense. You can set up the power on state, which can be on and off, or last state, and there is also a power up delay or a power up interval in milliseconds, and you can do the same settings for all the different outputs individually. So I've just left everything on the default, which is what you see in the screen. Let me skip the protocol definition. Next, you can set up some users. The default one is admin. You can create some additional users. As you can see, they can have different accesses. And within the settings, again, we see a few different settings. So that's the MAC address of the device. As I said, the default is the DHCP, but you can set a static IP address, which could be particularly useful if you are using some of the APIs. For example, for Modbus, you should have a static IP address, or pretty much the HTTP protocols as well. Maybe the only exception is the MQTT. So I'm just going to leave it on DHCP for the time being. Of course, you can set the time. You can specify what NTP server to pull the time from and what time zone you are in. You can update the firmware as well. And there are a couple of other system settings. So the device name, which we see up here, and also the HTTP port, you can move it into a different port if you need to. And you can also set up a periodic restart of the device. And you can also export and import configuration. So if you are setting up multiple of these devices to the same settings, you do it once and then you can export the configuration. And you also have some logs here. Yep. And now let's go over to the protocols. I mentioned previously that pretty much for everything there is an application note on the NetIO website. So if I go to if I back off from here, no, actually, let me find this box again. So if you open up the website, you can see the different application notes. And actually, this is what I've used to understand how the Modbus works. And besides the application note, you can also download the documentation for each of the protocol. So going back to the first one, and by the way, here in the protocol definition, you see that, for example, this protocol has a dot. So that indicates that at the moment, this is listening to Modbus messages and not everything else. So it can only work in either one of these protocols. So you have to specify if you enable the XML API and if you save changes, then as you can see, the dot moves to the XML API. So now it is listening to the XML API and nothing else. And just to give you a really quick idea, so the XML API is that you are sending messages to a specific URL, and within the URL you need to have a payload of certain types, and you can see a couple of examples here. So if you want to set the output to 1, then that's the XML that you would need to send to the device in the payload. So as you can see, ID 1, action 1, and that will set the output. In the JSON API, let's not do that. In the JSON API, again, it's really similar. You have a URL that you need to send the message, and of course you need to spend a specific JSON in the payload. And I think my system has issues understanding what a JSON file is. But anyway, I think you get the idea. XML is an XML file, JSON is a JSON file. URL API is even easier because you have to, as you can see, there is an example here how you can toggle output 1. So let me save the changes. And if I just click on this one, the output is toggled. So the first night light is on. And again, really, really simple. You see the URL /netio.cgi question mark pass, that's the password that you specified, and output 1 equals 4. And we have seen this concept in the other NetIO devices that when you are when you want to change the state of an output, you can send either 0 as off, or 1 as on, or 3, which is going to be a short off delay, or 4, which is going to be toggle, and 5 is nothing, or sorry, 3 is the short on. So 4 is a toggle. So I send this message out, or send this URL out, that toggles the output. If I repeat it, it's going to turn it off, and then it's going to turn it on again. So fairly simple. I think URL API is a very universal one. I've seen many home automation systems using that, like OpenHub, definitely Node-RED, but Domotic is able to just call URLs based on when something needs to happen. It's easier to implement that than the JSON or the XML API. I'm going to skip the telnet because that is something which is less familiar to me, but again, there is an application note, so you can use that. I haven't even mentioned telnet in the beginning of the document. Modbus, yeah, you can enable Modbus, and there is a whole documentation how that works. Since I'm going to talk about that a little bit later, I'm going to skip that for the time being. The same applies to the MQTT. There is a NetIO push protocol as well, in which the device is going to push messages to this particular URL every 60 seconds or every minute. In this particular model, it would be just a message which is containing the actual state of the 3 outputs. There is no power consumption measurement here, so it's just going to send the 3 output, and you can even specify whether that payload is in JSON format or an XML format. And we also have SNMP. I have to admit, I don't know an awful lot about SNMP, but this is a protocol which enables monitoring devices in a network. So this is how the professional network engineer usually monitor devices. So as I said in the beginning of the video, I'm going to talk about 2 protocols in more detail. One is going to be the MQTT, and the other one is going to be the Modbus. So let me just enable MQTT, and as you can see, we need a JSON file to configure the whole MQTT protocol. And it is the same concept, the MQTT flex config, that we have also seen for the other NetIO device. Obviously, they are using the same protocol. So let me go through this. But again, this device is fairly simple because you have three outputs. You can either change them and you can also get the current state of it. So I don't think there is going to be a great flexibility how this flex configuration document is going to look like. So pretty much you are going to just copy my example and then change the MQTT settings, and I think you should be off. Of course, unless you need to have specific topics, then you can change the topics. And I'm going to include this file in the video description, and it's going to be included in the sample Node-RED flow as well. So there are two main parts for this flex configuration. The first one is the broker config, and as you can see, you specify the URL, the protocol, which is obviously MQTT. You can specify the port and the SSL, which is actually really nice because it means that this device would be able to connect to a secure MQTT server, which is not, as far as I know, it's not true for ESP devices. And you specify user ID and password, and yeah, you can set the client ID. And that's pretty much it. And in the next section, you specified all the topics that the device needs to subscribe to. And of course, you need 3 topics because you have 3 outputs. So you want to listen to the topics to change these outputs. And again, I've used the default naming convention. So it's going to be NetIO / the device name, which is this PowerBox /91. That's why I said it becomes important a little bit later. And then /output /1 /action. And into this topic, you would send like 1s and 0s to turn something on and off. Well, actually, sorry, 1s and 0s to turn on and off. Or for example, 4 for toggle. So these are the things that I've already mentioned. So, or 3 for a short on. That's the section for the first output, the section for the second output, and the section for the third output. And as you can see, the only change in between them is, you know, /1 /2 and /3 in 2 places. So I think everything is quite self-explanatory. The next one is the publish, which again is going to consist 3 almost identical sections, 1 for each gang. And here you are specifying the topic the device should send a message to when the state changes. So again, the default is NetIO / the device name /output /state, and the payload is the actual state of the output. So again, it can only be 0 when the output is off, or 1 when the output is on. And in the event, you can specify at what time the device should send the update to this topic, and obviously you want to receive an update when the state changes, and that's the only event that you want to configure here. And once you have done a section for one of the output, then you can just basically copy and paste to output 2 and output 3, and the difference between these is obviously the /3/ here, and then you see, copy and paste. So 2 2 2 and 3 3 3, and you save changes, and now your device is in MQTT flex mode. So now I can head over to my Node-RED, and I've already done the flow. Well, that's the TCP flow, but we can look at the MQTT flow. As you can see, I've created 3 MQTT out nodes, and they are all have the topic that the device subscribe to. These are the topics that we have put into the subscribe section. So yeah, output 1 2 3 actions. And as I said, you can send these various values in. So if I send off, then the first night light turns off. If I send on, it turns on. And if I do toggle, then it changes the state. And I can do the same for the other one. For example, if for output 2 I send value 3, which is momentary, then it turns on for 2 seconds and it turns off automatically. I don't have to do anything. And of course toggle works here as well. And pretty much you can do the same for, output 3, but nothing is connected to it, so you don't see any state changes. And I have turned off the MQTT in, but if we do that, we can see all different state changes. The reason we are seeing two, because here in the topic, I just specified NetIO PowerBox 91/everything, so it is also echoing the messages that I send in. And of course you are getting a response saying that, yes, I've received the message and the output is off. And if you do something like a momentary, then first you get the one message, and then when the delay expires and it says to 0, then you are also getting the 0 message. I think this is, fairly self-explanatory. And it is so simple that I haven't even created the UI, but I guess you get the idea. You can have like a slider for 1 and 2, and maybe you can have simple buttons for momentary and toggle, and you just set the payload on the UI element to be either 0, 1, 3, and 4, and you just send it to the MQTT. So simple as that. So that's all about the MQTT one. By the way, if you want to get the MQTT Flex configuration message, you can come here, and I've pasted into the to the comment section of this comment node. And actually, let me change that. That was my copy and paste mistake from a couple of days ago. Okay, that's all with MQTT. Let's move over to the Modbus. So I'm now going to enable Modbus. We are using the standard port 502. And I'm going to save the changes. Okay, now we are on Modbus, and I go back to my flow or my Node-RED and show you the Modbus documentation. It's quite an extensive documentation, and there is actually so much different stuff in it, because if you just look at the number of Modbus functions that have been implemented. So first of all, the function 01 is implemented, so you can read the coils. So we have obviously 3 coils, the 3 outputs. So you can use Modbus function 1 to read the coils individually. You can also use Modbus 3 to read how many outputs are available on the device. So that would be 3. But when you want to change any of the outputs, you can use 05 to change a single coil. So that would be, one of the 3 gangs. You can either set them to on and off, which I'm going to do in this example. But you can also use number 6 to write a single register, because the outputs are also implemented as registers. So you can still send, 1s and 0s to the register, but you can also send 2 and 3 and 4 and 5s for various, momentary and toggle functions. And similarly to 5 and 6, you can also use 15 and 16 if you want to change multiple outputs at the same time. Other thing to note is the device ignores the unit ID, so you can set the unit ID to whatever you want, and then the rest of the document just talks about the various options. And when you set the registers, these are the various actions that you can use. So just like with MQTT, 0 is off, 1 is on, 2 is a short off, which is basically it turns it off and it turns it back on. And then the 3 is a short on, so it comes on and it automatically turns off. And 4 is toggle, and 5 is no change. I still don't understand why we need a separate function for no change. And yeah, there is an awful lot of documentation here. There is documentation about voltage and frequency and energy monitoring. Obviously, you can ignore that because that doesn't apply to this particular product. Out of all these functions, I'm just going to show you the 2 simple ones, how you can write the outputs. So going back to Node-RED, I've created a couple of Modbus write. So this is the simple write node. And the first 3 are configured to change the single coil. So I'm using Modbus 5. And by the way, in the configuration of the Modbus device, I just set TCP, the current IP of the device, and I think I've left everything on default. I just specified the unit. As I mentioned before, the unit ID doesn't make a difference. So Modbus function 5 is to change the output. Address 101 is the first output, 102 is the second output, and copy and paste, and 103 is the third output. And as you may know, Modbus function 5 expects either a true or a false in the input. So if I send a true, the output turns on. I can do the same for output 2, which is already on, so nothing happened, and the third output where we don't see anything. And on the output of each of these nodes in the payload, or sorry, in the debug, you can see the the various values. It's basically the echo of the function that we have sent in. And I've also implemented Modbus function 6. So these are exactly the same as the one above. The only difference is that the function is 6. So this is to set a single register. So again, the address is 101 or 102 or 103. And here I can send in 1 or 2, sorry, 0 and 1 to turn the output on or off. But I've used the other two options, which is 2 for a short off delay or 3 for a short on delay. And if I do that, so if I do it on output 2, which means that the star is going to turn off and it will automatically turn back on. So that's the short off. And if I turn off the star and I activate the short on, then it comes on and it automatically turns off. And with this, we reached the end of the demo. And as I said, if you are interested in any of the other protocols, then just head over here to the NetIO products website, look for this particular product. On the supported protocol list, just pick the one that you need and just click on the application note. And you will be provided with an example which has even more details on how this protocol needs to be used. You can have an online demo, and also somewhere here in the documentation, just like with Modbus, you can get the whole protocol documentation as a PDF file. And this was my review of the NetIO PowerBox 3PF. Thanks for watching, and hopefully see you in the next video.